First of all, I would like to thank Martin Clark, Mr. Martin Clark, and also Lafala University for giving me a good opportunity to talk about sustainability. I really don't want to speak English in the UK, but there is no way that is only to communicate with you. So please allow me to speak strange English. Okay. So as Martin introduced that, I'm working for the Kagawa University, and I'm chairing the ISO TC71 Subcommittee 8. TC71 is the concrete and reinforced concrete and pre-stressed concrete. And more than 3 years ago, that's when I created Subcommittee 8, which is the environmental management for concrete and concrete structures. And also, I used to chair the FRV Commission 3, which is the environmental aspect of the concrete. And also, right now, I'm chairing the FRV SAG 8, which is the FRV Sustainability Initiative. And also, I'm right now chairing the JCA Sustainability Committee. And there is the one forum in Asia. It's an Asian Concrete Federation. So the 2 years ago, we created the sustainability forum that we started how to do the sustainability in Asian countries. So this is my background. So today's my talk is quite on a broad view. So first slide. So this is the from the Earth past to present. As you know that the Earth is 4.6 billion years old. It's a long, long time ago, and life has evolved for 4 billion years. And but origin of the modern humans was born 100,000 years ago, not so long time ago. And we got agricultural revolution 10,000 years ago. Industrial revolution occurred in the UK just 250 years ago. So very recent things. And also modern cement was invented in the UK in 1824. It's quite recent if you consider the history of the Earth. And we developed, invented concept, sustainable development. And it was defined in 1987, which was done by a World Commission on Environment and Development. You all know that, and I don't repeat that, this is the concept of definition of the sustainable development. And but I would like to emphasize that we need to consider the future generation. That's a point of the sustainability. And 1997, a Kyoto Protocol in COP3 was adopted, but entered into force just in 2005. And next month, this year, UN Conference on Sustainable Development called Rio+20 is held in Brazil. This means that 20 years ago that we got the Earth Summit in Brazil. So probably they reviewed what's happening for the last 20 years. So this is the idea, what history we have. And we can say that what's happening in the Earth's climate since its birth So as you know that the Earth repeatedly experienced climate warming and cooling due to two reasons. One is the change in gases in atmosphere, which come from the major volcanic activity, photosynthesis, and also asteroid collision. And the other change is the inclination of the Earth's axis of the rotation and eccentricity of its orbit. So it's very complicated, the climate change. And there was the carbon cycling on a geological time scale from CO2 gas to carbon fixation in the Earth. And also there is the rapid increase of atmospheric CO2 levels. This means that acceleration of the global carbon recycling by ourselves. So global warming by greenhouse gases. But a few years ago, we got a climate gate scandal in the UK. But let me, as all we know, but let me show the data of the planet in the solar system as shown here. This is the sun, the temperature of the sun, 5,500 degrees Celsius. And the Mercury, which is the nearest planet, but temperature is the 167. The Venus is far than the Mercury, but the mean temperature, 464. So this means that this Venus has a high concentration of the CO2, 96. So this shows the greenhouse gas effect. It's quite clear. Our planet, Earth, is the mean temperature is just 15 degrees. But the CO2 concentration is 0.038%. The question is whether or not this carbon dioxide affects, how much it affects. But nobody knows that. And also Mars is quite far, and thin atmosphere. As a result, the temperature is very low. So what we can say from this fact, there is the greenhouse gas effect. There is no doubt about that. But we don't know exactly how much it will affect us. Then, do we ignore that? So that's a question. What do we have to consider? How to deal with that? Then based on these information that I would like to talk about natures of the concrete industry. The concrete industry is essentially a local industry. It means that concrete structures are built by local people using local materials. There is no doubt about that. And also the component of the materials concrete it's very simple. Aggregate, cement, water, others. This means that concrete is made from the most abundant substances on the earth. And this is the main reason why its production has been able to expand to respond to growing construction demand. And concrete is the second most consumed substance on the earth after water, more than 20 billion tons. And we can say that a contemporary society cannot exist without concrete. It's quite clear. And development of the nation is directly correlated to its consumption of the concrete, namely the increase of construction investment. I will show you the fact. This figure shows the world cement and steel production since 1950. I put the 100% in 1960. So you can see that this is the cement production. So it became the I think that's more than 7 times. And also steel production. This is more than 3 times, I guess, 2.5. And this is the population. It became the double, 2 times. And due to the construction investment, the GDP increased drastically after 1960. So from this figure that we can say that infrastructure development by utilizing cement and steel increased the GDP per capita. And this is also a very interesting figure. This is the construction investment per capita US dollar, and this is the GDP capita US dollar. So there is the proportion between construction investment and also GDP. It's quite clear that this is the US and also France and the UK. It's a very similar trend. And this is the Germany and Japan, a bit different from the other country. In case of the German, probably this came from the merging of the East and West Germany. So Japan, it's quite difficult to explain, but since 10 years ago that the investment is decreasing in this stable situation and close to the other developed country. This is the fact. So that we can say that the construction investment is very important in the GDP's point of view. And next topic is what are the problems on concrete from the sustainability's point of view. So we need to know what we are doing. First is that inadequate safety and reliability of concrete structures to unforeseen external force. And enormous consumption of natural resources, as I mentioned that 20 billion something only for concrete, more than that. And also because of the consumption of cement and steel, that generation of a large amount of CO2. This is the one aspect. If you look at safety and reliability, we can say that our design standard and the specification on safety have been improved based on many experiences from serious disaster. But for example, severe earthquake, especially in our country. And also, however, we have still problem that we cannot foresee. And therefore, it is reasonable to think that we cannot control the movement of the earth. So based on that fact, we need to consider something. Japan disaster, March 11 last year. So what was the Japan disaster, March 11? So that was the triple disasters. Earthquake, magnitude 9.0, and tsunami, and radioactive pollution due to the hydrogen explosion of nuclear power plant. So here is the some data. Deaths and missing, approximately 20,000. Destruction of the houses, approximately 370,000. if minor damage included, more than 900,000 houses, and evacuees approximately 320,000 people. And nuclear power plant, we have the 54, but right now, nothing under operation, all stopped, because people don't like, and in every 1 year, they need to maintain nuclear power plant. The ones right now stopped the nuclear power plant. It's quite difficult to reoperate because the people are against. That is the current situation in Japan about nuclear power plant. And tsunami, you may know that. I will show you a couple of slides. This is the disaster. Some concrete structures are remained, and you can look at that. So all wooden house structures gone, and only some reinforced concrete remained. And some bridges fell down because of the lateral load by tsunami. So we didn't consider the lateral force in the bridge so far. So from right now, we need to consider for the future. And nuclear power plant, some building like that. This is the damage of the railway viaduct columns. There are many such kind of the destruction, and bridge shoes also, and the power pole in railway, and port and breakwater as it fell down. And again, that Japan disaster is earthquake destroyed social and economic infrastructures. Social and economic infrastructures. The earthquake caused tsunami that also destroyed the infrastructures and houses and buildings. The tsunami destroyed the electric power facilities that led to the interruption of the cooling water supply. The hydrogen explosion in NPP occurred, and radioactive substances scattered over some regions. So what are the lessons from Japan disaster? Firstly, without robust infrastructures and houses in the building, human society has no chance of sustainability. This is the basis. Sustainability consists of the environmental aspect and economic aspect and social aspect. And this is the common category that we have to consider. If you look at the environmental aspect, we can say that crustal deformation changed natural environment. This means that nature destroyed nature, not by us. Huge amount of level was generated. This is the big issue right now in Japan. Without doing something or level, we cannot rebuild the structures in that region. And huge amount of resources and energy are necessary from right now to rebuild infrastructures and houses and buildings. And radioactive contamination occurred in some regions. This is the environmental aspect. How about the economic aspect? The economic activity in the regions collapsed, of course. A cluster of the plant producing automotive and electronic parts that served the world stopped. So that fact affects a lot to the world. And because of that, the overseas transfer of the manufacturing plant will be accelerated. That's what we are expecting, thinking. And many people lost their job, and therefore income. And a huge amount of the investment is necessary to reconstruct a region. And also cleaning up radioactive contamination is needed from right now. It takes maybe 10 years or 20 years more than that. So this is the economic aspect. It costs lots. And how about social aspect? There are 20,000 victims, and also many people lost their homes. A long-term evacuation of a local population is expected due to the radioactive contamination. And many jobs were lost. So this is the fact which we are facing right now in some region of Japan. And what is the essence of the sustainability? We can say that destruction of the social infrastructure and facilities exert a lethal negative impact on economic and social activity. In other words, the basis of sustainability collapsed. On the other hand, we can say that simple expansion of economic activity using the infrastructure is not desirable from a sustainability perspective. And measure increase in resource and energy efficiency to facilitate economic expansion is the ultimate goal, which is the essence of sustainability. And consumption of natural resources, so if you look at that, aggregate 11 billion tons, limestone 3 billion tons, and clay 540 million tons, water 1.5 billion tons. That's a rough calculations. And a total for resources used in concrete is more than 16 billion tons right now. And problem in concrete and steel productions, I don't repeat that. And we can say that no material can replace concrete and steel. For example, wood has an extremely limited range of the use for living and activities of 7 billion people. So this is a fact. And let me talk about a little bit about CO2 emission sources in the concrete industry. First is material manufacture, cement, reinforcing bar, aggregate, water, admixture, concrete manufacture, execution, repair and strengthening, and also demolishing and recycling, transportations in each stage. And this is the world cement production in 2010. Total production is 3.3 billion tons. 56% of the cement production is in China. And from right now, India, the population of the China and India is almost same. So it means that in near future, the India's cement production drastically increase. So this is the situation. And world steel production, again, 44% in China. In Japan, it's less than 8%. This is the fact number. And CO2 emission in concrete and construction industry, I calculated roughly, according to that, concrete industry, 5 billion tons. And construction industry, 6.3 billion tons, which is more than 20% of the CO2 emission of fossil fuel origin in 2007. So it's quite a large number. And I would say that these figures may be conservative. And the future, how about future? If it became a double, 10 billion tons, 34% of the CO2 emission of fossil fuel origin. And the construction industry, amazingly, 43%. Of course, at the same time, the other industry is emission will increase, so that because of that, we need efficiency and innovation in cement manufacture. I don't want to talk about CO2 emission in cement production, come from the decarbonation of limestone and combustion of fossil fuel. And what are the possible measures to reduce CO2 emission? Reduction of limestone and reduction of fuel by lowering insulation temperature while improving thermal efficiency of the inclination, insulation. And use of biomass, because it is regarded as a carbon neutral. But there is the limitation in its availability, as you may know. The use of the fossil-related waste, CO2, because CO2 is less than that from virgin fuels. And this is the the figure, international comparison of energy consumption in cement clinker production. I said the 100% in Japan, so compared with the other countries, so quite low level. And also this is the unit-based CO2 emission in cement manufacture. Again, the Japan is the lowest. And possibility of CO2 reduction by improving energy efficiency. And based on that, the figures that I calculated, under some assumption, the energy consumption can be reduced to 67% of the current level by introducing Japanese technology. It's a very simple calculation. Then CO2 emission can be reduced by 13%. So there is things that we can do right now. Let me talk about prospect toward sustainable concrete construction. Firstly, efficiency and innovation in cement manufacture. This is very important. And also we need to utilize supplementary cementitious materials. All of you know that. And also by utilizing high-range water reducing agent, we can reduce the carbon dioxide by reducing the amount of the cement. And this is very important. And the high-performance concrete and its application to structure design. By utilizing, for example, super high-strength concrete, you may be able to reduce the environmental burden. So this is the one of the key factor for the future. And also efficient transport and execution. Not only manufacturing of the materials, when we construct structures, we need the transportation and also the other machines. And efficient use, for example, in this building operation, and demolition and recycling. And development of the innovative technologies, zero carbon and minus carbon concrete nowadays, and net zero energy building, they're becoming popular. And secondly, we need to establish the impact evaluation of environmental design system. Without this kind of a system, that we cannot evaluate how much it affects. And in other words, rating systems, ISO standard. The UK has the BREEAM rating system. And quite recently, building information modeling is becoming very popular. When you design a structure that by introducing the building information modeling, that you can check everything that's very briefly. So you can choose what you want. And lastly, this is very important, how to balance of safety, durability, and resilience with environmental stewardship. So far, we have been focusing on environmental aspect. But after the March 11 in Japan last year, that's when I realized that if you consider the sustainability, we need to consider the balance of those aspects. That's the main topics of today. This is really essence of sustainability. And regarding the new technology of the innovative technology, especially CO2. This is a new technology in the USA. If CO2 can be captured and if a sufficient amount calcium ion is present, one can produce limestone by their chemical reaction. So that the one company in the US are trying to do this. A technology, they developed a technology to form calcium carbonate by passing carbon dioxide from thermal power plant through seawater. And this is the data. So the little bit lower than the case when we utilize ordinary Portland cement, but it works. And also the UK has the one brand, Novacem. I don't want to explain, but all of you know that. But this is limited in the masonry product. We cannot apply this kind of the concrete into, for example, building or bridges. It's a very limited application. And also by Lafarge, B-light calcium self-aluminate ferrite type clinker, they developed. Ingredient limestone, bauxite, and sulfate calcium, according to their information that CO2 emission reduction from raw materials is 25%. They produce this cement by utilizing in actual kiln. And the point is the calcination temperature lowered 1,300. Normally 1,450, something like that. So, and also there is one technology developed in Japan, fluidized bed cement kiln system. Left-hand side is the normal kiln. There is a kiln. But this system is very this kind of shape. And here is fluidized bed quenching cooler, and also a fluidized bed sintering kiln. So it's very efficiency of the burning is great in this system. And according to this system, the CO2 reduction will be 10 to 25%. And NOx reduction is 40%. It's amazing. And also, quite recently, one project was completed in Japan, and they developed the carbon negative concrete block. And this is the thermal plant chimney. And they took the CO2 into this chamber, and you put the concrete block here and emit the rest of the carbon dioxide. And this is the point. The main materials of the concrete is the fly ash as a cement substitute. And also they are using special admixture. This is the chemical components that react with CO2. So this is a normally ordinary concrete, and by utilizing this fly ash cement, you could reduce this amount, and also absorb CO2. So the as a total, the negative concrete block was made. So this is quite recent development, and also this is the production of a recycled aggregate system. That this is the plant, real plant, and they made a recycled aggregate like that. It's a quite good aggregate recycled, but the system is heating and leveling. So when you heat the demolished concrete, you need energy. So the point that we need to reduce to do that. So we need to further development for this system. Let's talk the future perspectives on sustainability. The background is global population reached 7 billion, and we need to balance, as I mentioned that. This is the key in sustainability. And 3 scenarios are possible. And one is this condition, and also scenario 2 is like that. The element is the population living standard and also resource energy efficiency. And this is the scenario 3. So this is the conceptual idea, the production of the goods and services, and resources and energy consumption, and environmental burdens. So the current technology is like that. If you increase of the production, you have to increase the environmental burden, and also you need to consume resources and energy consumption. So that is a scenario 2. And the best one is scenario 3, is the environmental burden decreases and production is increases, and resources and energy consumption decreases. And in the construction, how about the concrete and construction industry? The robust building and infrastructure are the basis of sustainability, as I mentioned that. And if the population increases and living standard rise, and demand for buildings and infrastructure development increases. And as a direct or indirect consequence, resource and energy consumption grow. Therefore, as I mentioned, that scenario 3 should be the target of our industry. And problem to be solved, the balance is very important. And there are major issues regarding the robustness of existing building and infrastructure. And available technology and assessment rules for reducing all negative impacts are not adequate. So that's why we have to do something. But always we have the conflict between structural, safety, and reliability environmental issues. Because if a large degree of the redundancy is adopted, it means that degree of the safety increases, but this generally increases the amount of resources and energy used. And if a low level of redundancy is adopted, high efficiency resource and energy consumption results, but the degree of safety decreases in respect of actions exceeding the assumed level. So there is a conflict between them. And design, as a design basis of the concrete structure, I would say that it is not economically practical to design a structure that completely exclude destruction by unforeseen great external forces that may occur in the future. Therefore, it is very necessary to provide a level of the performance that hold damage to the level of the partial destruction without collapse of the entire structure in the case of the unforeseen great action of the very low probability. That came from the March 11 last year. This is not new idea, but we realize that this idea is very important. Again, this is the scenarios on safety and environmental burden. This is the burden, and the safety increases. So if you utilize the current technology to increase safety, which means that the environment burden increases like that, but the ideal direction is like that. By safety increases and also at the same time environmental burden decreases. So this is the idea. But I will show you the lastly one example how to accomplish this. There is the RC rigid frame viaduct, and there are two ways, ordinary viaduct, and also there is the viaduct introduced innovative technology. I'm not going to the detail. This is the side view of that. This is conventional, and this is innovative one. And I calculated the carbon dioxide. So it's more than 25% was reduced by using the new systems. And this is what happened in site damaged by the last year's disaster. So this is the conventional structure, and this is the innovative technology introduced structure that there is no damage here. And there are damage. And this structure used more resources than this. So this is the one example. There is the possibility by reducing the environmental burden, we can build the more safety structure. Yeah, this is the conclusion that there are several ISO standards for environmental aspect and also sustainability, including ours. And 14,000 cities very famous. And also there is the ISO TC 59 and subcommittee 14 and 17. They are also developing the standard, ISO standard for sustainability. But the problem is that this is ours. Problem is that the existing of standard is very conceptual. So it's quite difficult for us to apply the existing 14,000 cities or other environmental standards. So that's the reason why I created the new subcommittee in ISO. So I would say that ISO 70 TC71 subcommittee 8 will provide very clear rules that do not cause any misunderstanding and confusion, so that if you utilize this standard, you can calculate without confusing and misunderstanding that. The structure in this is what we are going to develop and framework. And this is the our first ISO standard. Last February, we published this one. This is the general principle. And also, we are now developing the part 2. And I hope that 1.5 years, within 1.5 years, and we can produce that. This is very important part, because this is the system boundary and inventory data. How to set system boundary and how to calculate inventory data. So all rules are included in this part. And this is the system boundary of cement production and concrete production, execution, and even in use of concrete structure and demolition work. And everything are included like that. Finally, concluding remarks. Human being invented a great idea, sustainability, at the end of the 20th century. And from the idea, our problem has become quite clear. And for ourselves and future generations, it is very important to create the reasonable systems which achieve sustainable society. Concrete is the keystone for that. In contemporary society, almost all people utilize infrastructure and spend long period of time inside houses and buildings which are built with concrete. Therefore, creating safety structures with low environmental burden, which is the essence of the sustainability, is the responsibility of those of us working in the concrete and construction sector. We have to avoid the conflict in sustainable development between emerging and developed countries. But the question is how. There is the conflict between sustainable developed country and emerging country. Concrete, finally, the concrete, there is no other alternative. This is my conclusion. Thank you very much for your kind attention.